Welcome. I am Nimish Malik, roll number 20EC10054, and this is my Arduino project. It's basically a slightly smarter version of a traffic light. For instance, in less traveled areas or areas which aren't very crowded, it's quite common to have traffic lights that are going on for no real reason. Since there's only cars on maybe one or two streets at any given time, so those red lights, that time is essentially wasted when there's green lights, but no cars actually need to pass through. This is mainly the situation in like less traveled roads, but also during midnight hours or times when oftentimes red lights are just closed down in order to save time, which can still be risky because people tend to drive fast and don't actually look around if there are no red lights. So to deal with that, this is a really simple method of essentially there would be sensors on each incoming pass, which could tell you if there's a car there or not. The sensor itself would be really simple. I've used a button here to simplify the circuit, but essentially it would probably be a light detector with a LED or a ray of light coming from the other side of the road, and if it doesn't hit the detector, there's a car in between or something in between. But to simplify things, I've just used a button to say if the button's pressed down, there is a car. If it's not, there isn't, right? So in this case, currently everything is red. Now in a normal scenario, all of the buttons would be pressed, right? Cars are everywhere. And in that scenario, it will work completely like a normal street light. Just switching from red to green, from red to green, from red to green. Just a cyclical pattern, as you would assume normally, right? The simulator just died. Oops. But in this scenario, right here, for instance, I want to say maybe this is number 1, right? So if I want to say that maybe there are no cars in front of number 1, there are no cars in this street. So the board will see that, recognize that, and say, well, okay, they don't need a green light, so just skip them and go to the second one. I basically just did this by having 4 inputs. I'll just stop the simulation now for the second. Just have 4 inputs directly connected to 13 through 10 of the Arduino board, connected through buttons. So when the button is pressed, the input measures out as 1. When it's not pressed, it's 0. And the voltage difference can be measured using these voltmeters. Apart from that, there's just a resistor in between, just to make sure that the current isn't too big and break the Arduino board. Once those inputs are taken in, it's just a simple read, right? It just says what that input is supposed to be, is it high or low, and then gives a corresponding output here. This output then I have connected to these LED lights. Each color of wire represents which input it is. So for instance, 13 is the input and 6 is the output for the same color, the first LED light, which is this one, right? This one. Similarly, so all of the others are connected. Now these lights themselves are RGB lights, so they have multiple inputs, as you can see. So for the red color, which is always supposed to be, I basically just passed the outputs through a NAND gate, but I'm honestly only using it as a NOT gate. So I basically just pass them through a NOT gate. So if the color isn't green, if there are no cars, it will stay red, right? So back to the code, we can see that what it essentially does is, in a loop, it checks what the input is, right, what the digital pin is reading, and if that input is positive, it goes through the cycle of setting the color. The pin 6 to high would turn the light green, then back to red, right, and a small break in between. I could have added yellow color as well, but that just would have taken more time and would have looked very messy here. So I skipped on that part. Instead, I just gave a second of break after one light turns green before the next one can turn green. Oh, before the next one, you get it. Similarly, it'll just check for the next one and the next one and the next one, and if there are no cars, it just skips the green light, right? It just stays red and it goes on to the next step. In here, initially I was trying to use the transistors to make the red light work without a NOT gate, but that didn't really work out. I still have the transistors. They aren't really that important. At the end of this, I can remove the transistors from the design. I just haven't done so yet because it's a lot of rearranging wires. But essentially that's most of it. Now the thing about this is that the hardware is not very complicated, right? It's just 4 inputs, 4 outputs, and a NOT gate. That's essentially what all of this is. Everything else is just measuring or stopping things from breaking. The important part here is the code, right? Now obviously the code I've written is really simple. It's not very complicated, but that's just for an example, right? Because it gets the idea across of what I want to do. Now some of the pretty obvious benefits or pretty obvious improvements that could be here, for instance, making it a little bit better. So instead of just checking once when the red light is turning to green, it checks multiple times. So if there's only one car, right, you still don't have to wait for the entire, for instance, maybe 20-second green light. Maybe that car left within the first 3 seconds, then you can switch back to it being a red light. So that's one method that could benefit this. Another one that I thought was important and could be used in this is, for instance, in this code, I just used 5 seconds of green light as, just an arbitrary number. It doesn't really have to be 5. The thing is, while I'm no like engineer or no, I don't really deal with roadways. Any kind of cross section will have different values where the green light is either too long, so you're wasting time when no one is passing through, or too short, in which case you waste time because people have to accelerate, right? So in fact, the amount of cars going out of a green light increases with time to a certain extent. So you want to find a good middle ground, right, for green lights. And this is a good way because you can just have the computer take all of the information about how long it generally takes for a single light to completely be cleared, and even arrange it to edit that number on the fly. For instance, maybe repeatedly, for instance, let's say I took 5 seconds, right? And repeatedly the system noticed that while everything else was busy, maybe the first red light kept ending early. Well, obviously I haven't set it up here, so you won't see that. But for instance, it noticed that the first red light or the first green light, it only needed to last for about 2 seconds instead of 5, and then there were no more cars. So slowly it could, especially if it kept on happening, it could decrease the length of that green light and distribute that time across the other 3 lights, right? So they have longer green lights until it gets to a balance where the time is being used most efficiently. So all of that is just basically software and coding, a lot of statistics generally. It doesn't have to work that way. It can, because I get that it's complicated, and having something doing those calculations in every red light is unnecessary and not the most important thing ever. So you could have it just store the data and send it to a central location once maybe a month or 2 months, and that just recalibrates in general how long the green light has to be. But obviously all of that code is more complicated than I can do on blocks. So that I have done what is like quite simple, but it leads quite easily into the other things as well. So yes, that is most of my project right there. There could be a lot of improvements in this, especially as I've said in the software design. Also, for now I've just used buttons, but using proper sensors and maybe even field testing it would be quite helpful in figuring out what's left, what's actually being useful, maybe things that I can streamline in the entire design. But for now, yeah, that is the most of the project. Thank you for watching.